Welcome back. Without further delay, I'd like to get into the content. Now, this video is based on the assumption, and if you're watching this, then there's the assumption that you understood how to do R and S for the three cases I've shown. One where the low priority group is already either in the front or back position. And the second case is flipping and then flip back again to figure out what was the conformation on the original molecule. And the third was the ring structure. Okay, now if you have not understood, nor you've not done the practice that I gave you, and you don't have any clue what R and S is, then this video is probably one of the two videos left in the concept of stereochemistry will be of no use. But say you understood, but maybe you are 1% lagging, but I guess you can still catch up and understand it. So with that disclaimer, let's get started. All right, for the first one, remember I said 5 key ideas. First one obviously is enantiomers. Enantiomers are basically, if you try to take a reflection of your palm with your fingers on it in a mirror, it looks exactly the opposite. Okay, they don't match exactly the same way, right? So that's called an enantiomer. A mirror of your palm is the exact opposite. Okay, that's an enantiomer. Okay, so here's how you do it. Okay, and I'm going to put this as well. Now, let's start by identifying our chiral carbons in molecule 1. I'm going to call this molecule 1. I'm going to call this molecule 2. Okay, I'm going to redraw molecule 1 just for, so it doesn't become too crowded in one particular area. So let me redraw this. And the hydrogen is coming in the back position and the Br is in the front, or H is coming out, Br is coming in, Cl is coming in, hydrogen is coming out, or it's in the back and Cl is in the front. Now, this is not a chiral carbon. This is a chiral carbon. This is not a chiral carbon. This is a chiral carbon, and this is not a chiral carbon. Why is this a chiral carbon? This carbon is attached to hydrogen, Br, and this whole thing NCH3. None of them look identical, right? Now, how do we assign priority? With respect to this carbon, the first point of contact is Br for this one, so that's 1. By default, hydrogen is always 4. Between these two, this is 2, because, see, think about it. This is, as I explained earlier, they're both carbon attachments is the first point of contact, but this is attached to hydrogen and a whole bunch of other things, whereas this is only attached to hydrogen, which makes this a bigger group. So that's number 2. So this is number 3. Connect the 1, 2, and 3s. That's clockwise, right? And your lowest priority group is in the back. So clockwise back is R. All right? Let's do the same for this one. For this one, I'm going to do it here so that it's not crowded. Okay, again, the first point of contact is 1. This is bigger, so it's 2. This is 3, and this is 4. Connect 1, 2, 3. That's counterclockwise, and it's in the back, so that's S. So the sequence is starting from left to right, okay? It doesn't matter which way. I always prefer to do left to right. So it's R, comma, S, right? That's the configuration for these 2 carbons in the sequence. Let's go to this one. Let's repeat it. So let me redraw this. Br, hydrogen, hydrogen, and Cl. Okay, again, these are the only 2 chiral carbons in the molecule, not just because it contains the 3-dimensional view. I could have 3-dimensional view, but probably have something that are identical. So that's not, as I mentioned, that's not a key requirement. It's just 4 different groups. So the first point of contact is this, so that's 1. This is usually 4. And this is carbon, is attached to carbon, but then this is attached to this giant thing, so that's 2. This is 3. Connect the 1, 2, 3. That's clockwise, and it's in the front position, so clockwise front is S. For this carbon, again left to right, and let's do the for this one here. So 1, this is 4, this whole thing is 2, this is 3. You connect it, it's counterclockwise and front for the lowest priority, so that's R. So R and S. So if you look at the sequence, whether you do left to right or right to left, you got to keep it consistent. So this molecule 1 is R and S, left to right. Molecule 2, the sequence is S and R for the same carbon, right? Keep in mind, I switched these position, but still this only has Br and H. Keep that in mind. These molecules does not contain a new element between these two. They contain the same. If it is RS and it's opposite in the other, SR, these are enantiomers. That's what I meant by if the configurations in one molecule is exact opposite to the configuration in the mirror image of the molecule. So molecule 2, this is how we draw a mirror image in chemistry, at least. We don't draw an actual mirror, but we show the mirror image. So mirror 2 is a mirror image of mirror 1. So these are enantiomers. Let's finish diastereomers in the same context. Okay, so this is enantiomer practice, by the way. So I want you to practice and identify whether these molecules are enantiomers or not. So this is compound 1, or let me call it A. This is B. Okay, these are 2 separate compounds. These are the molecules. These are the mirror image ones. Okay, I want you to tell me whether these 2 are enantiomers or not. With that said, let's go to diastereomers. I'm going to put this again. Diastereomer is when configuration is one molecule is not exactly, that's the key word, not exactly opposite the configuration in the mirror image. So this is molecule 1, this is molecule 2. I'm taking the mirror image. If the sequence are exact opposite, then it's an enantiomer. If they're exactly the same, that's identical, which is what we're going to do in another video. But if they are partly same, partly different, then it's a diastereomer. So again, this is 1, this is 2, 3, and 4. So clockwise and back is R, right? Right? And this is 1, 2, 3, 4. Counterclockwise, back is S. So this is R, comma S. We should do the same sequence. If you get the same sequence, that's identical. If it's exact opposite, that's enantiomer. If it's somewhere in between, it's diastereomer. So this is 1, 2, 3, and 4. So that's clockwise, and back, that's R. Right? It's clockwise and back is R. This is 1, 2, 3, and 4, right? So counterclockwise and front is R as well. So this is a diastereomer because if it's exact opposite of what the letters you have RS and you have SR, that's enantiomer. If you have RS and you have RS, that will be identical. There's no reason for me to, I'm going to explain with an example, but I'm just saying that here because it's the same. This is a diastereomer. Okay. Now again, getting this part is easy. You just have to understand first how to do a basic R and S structure. And I think I've explained that here as well, but I recommend you go to the previous video and learn this. So I'm going to stop this video here. In the next video, I'm going to show you identical and meso, and then we'll be done. All right, stay tuned.